Hello class, this is lesson 4-5 about scientific notation. Now the first term is called standard form, and this is just talking about any regular number. So kind of our starting number, it could be really big, a huge number with tons of zeros, or it could be a tiny decimal, again with tons of zeros. But scientific notation is the condensed form. This is what scientists use so that they don't have to write all of those zeros in their huge numbers with their calculations or their itty-bitty tiny numbers, if they're dealing with the size of atoms. So for instance, 99 billion, if I was going to write this in scientific notation, I would start at the decimal point and I would go backwards all the way till I am right before the first digit. So that would be 9.9 times 10, and the number of jumps, I went 10 jumps backwards. So it would be times 10 to the 10th power. Like I said, it could be a tiny decimal with a whole bunch of zeros, all right? Like this made up number right here. And if I was going to turn this into scientific notation, again, I would be moving that decimal point until it's after the very first digit that is not 0. Okay, so this is really 2.4 times 10, and the number of jumps I had were 13 jumps, but because it's a decimal, we're going the opposite direction, it's going to be a negative exponent. So just kind of some tips for yourself is first, again, you want to move that decimal point, okay? And some numbers might have a bunch of other digits that are not 0, so you want to make sure that you move it until you have one digit that is on the left hand side of that decimal point, okay? And then the other tip that I have for you, again, is just be very careful with those little jumps that you're drawing underneath, because that is going to tell you the number for your exponent. Okay, so the number of jumps is your exponent. So why don't we go ahead and do some problems so that you can get really good at this. So here we have 725,000. So I'm going to start all the way on the right. That's where the decimal point is for a whole number. And I'm going to move it to the left all the way in between that 7 and 2. So that's really 7.25. And I did 1, 2, 3, 4, 5 jumps. So 10 to the 5th power. All right, 8,021,000. I'm going to move that decimal point all the way right between that 8 and 0. So that's 8.021 times 10 to the 6th power. Okay. All right, this next one is a humongous number. Look at all of those zeros. And I'm going 9, 10, 11, 12 jumps backwards to the left. So that's 9.002 times 10 to the 12th power. Okay, and then one more, I have 32 billion, 80 million. I'm going backwards 6, 7, 8, 9, 10 jumps backwards. So that's 3.208 times 10 to the 10th power. So again, let's just kind of give ourselves a little note. If you notice, all of these were large numbers to begin with. So just think about it this way. If it is a large number, right, like in the millions, the billions, the trillions, it's going to have a positive exponent when you're writing it in scientific notation. Okay? So why don't we go ahead and move on to some decimals. All right, I'm going to move this decimal just past that first non-zero digit. So that's really 1.6 times 10. And I did 3 jumps, so that's going to be -3 for the exponent. Now this next one, we're going to go 1, 2, 3, 4 jumps to the right, just past that 2. So that's 2.0 times 10 to the -4 power. All right. Let's move on. 1, 2, 3, 4, 5, 6 jumps to the right. So that's going to be 5.1 times 10 to the -6 power. So now look at our next example. There's a bunch of numbers there. So when we are moving to the right, we're going to be moving just past that first non-zero digit. So it's going to be 1.0452 times 10 to the negative 3 power. So what we can learn from these decimal examples is that if you have a decimal, like a tiny decimal, then it's going to have a negative exponent. Okay, so it's going to be a number that is smaller than 1. All right, so let's go ahead and move on now. We're going to turn scientific notation back into standard form. So what would help is if you rewrite the problem to give yourself some workspace. So then I can do 7 jumps back to the right to make it a bigger number. And I'm going to fill in all of those jumps with zeros. So I'm going to add 6 zeros there. And now I can rewrite my answer nice and neatly. And then I can add my commas in. So that's going to be 32 million. All right, let's go ahead and do our next one. So 7.12, and we're going to go 1, 2, 3, 4 jumps to the right. I'm going to add 2 zeros there. So my final answer is 71,200. All right, final one at the bottom, 5.599. We're going to move this 8 times to the right. So 3, 4, 5, 6, 7, 8. Put my decimal point. I'm going to add in those zeros now. 1, 2, 3, 4, 5 zeros. And so now I can go ahead and rewrite this so it looks nice and neatly. And then I can add back my commas. So it's 559,900,000. All right, so now starting when I have negative exponents, remember we're going to go backwards to the left. So 1, 2, 3 jumps, put your decimal point, and then I can add my zeros. I'm going to put a 0 before the decimal point and then fill it in after. All right, let's go ahead and do this again. 1.93, and I'm going to move backwards 5 times. 1, 2, 3, 4, 5 times. Put your new decimal point down and then add in those zeros. 1, 2, 3, 4. So this is going to be 0.0000193. All right, final one here. So 3.641. We're going to go backwards 6 times. 5, 6. Put in my decimal point and add all of those zeros. All right, so this is 0.000003641, and I'm done. So I hope that this lesson made sense to you. Let me know if you have any questions.